So problem solving with similar triangles. So we have a problem solving question here. And they're asking us for the length of the tunnel, which is this space between what looks like two smaller triangles within a much larger triangle. First, we'll kind of highlight the first small triangle, which they've given us some of the measurements to. So the hypotenuse of this green triangle is 420 meters, and the height is 250. There's a little red triangle. I don't know what color this is. Maroon or something? What color would you say that is? Magenta? Magenta. All right. The height of that one is 275. And then the distance from, and I guess I should give them some coordinates. We'll call this A. We'll call this B, C, D, and this could be E, F, G. Sure, we'll give those all letters. The distance from B to D is 550 meters. Now, because each of these triangles have this right angle base, okay, and they have angles that are the same of the greater triangle, so it's kind of hard for me to highlight the greater triangle. I'm going to recreate it, probably not quite the scale. Let me go 1, 2, 3, 4, 5, 6. It doesn't quite fit the scale. Looks something like that. We're going to highlight this one too in yellow. So I want to point out some things about this triangle here, so that way we know they're similar triangles. This angle here is shared. So we'll call that angle A. It's shared by the bigger triangle and the smaller green triangle, therefore it's the same. Thank you. Also, this green triangle is a right angle, and this one has a right angle. So if two angles are the same within a triangle, so this yellow angle here and this 90 degree, we'll call this one A again. So angle A is the same in both the green and the greater yellow one, and they both have a 90 degree angle. That means that this angle here must also be the same. Okay? So whatever it is the same. With that same notion, it's called F technically, with that exact same notion, I'll use the color red here for F, angle F in here, because this magenta triangle shares angle F with the greater yellow triangle, that angle's the same. It also has a right angle, which this one does. That means this angle here would also be the same as angle F. If all the angles are the same, that means they're just scale factors of each other. They're what we would call similar triangles. So you technically have to, in a question like that, you might have to state something like this. I know these are similar triangles because I have said shared angles or something like that. But once you've established that, we can start going through similar triangle rules. In fact, it may not be a bad idea to redraw all these. The key here is we're going to need to find out the distance of this tunnel. In order to figure that out, we're going to need to know the hypotenuse of magenta triangle. We're going to have to find the hypotenuse of this longer yellow triangle, that greater triangle. And then we're going to have to take the hypotenuse of the green triangle and the hypotenuse of the magenta triangle and subtract them from the hypotenuse of the yellow triangle to get the tunnel. There's quite a bit of work in this question. Okay? I'm going to break them into 3 different triangles, so the green one, magenta one, and the yellow one. I'm going to put them side by side so that we can compare them a little. Okay? So we go down here. Let's do green triangle. So color it in green here. Great. It looks like it's about the same as the magenta. So I'm going to say this is green triangle right here. It's not going to be the scale. We just want to get the values here. So this is 250 meters, and this is 420 meters. And then our magenta triangle, magenta, does that look magenta? Maybe. It is 275, so a little bit taller. Not quite the scale again. We do it right. So this is 200, oopsie, 275. I should move this over to make it simpler to work with. 275 meters. So we have that height. And then finally we have our very yellow, very large yellow triangle. There we go. We're going to need some space for this one. Let's say it's this guy here. Oh, that's not very easy to see, is it? That's tough. We only have partial height of this. So we can actually figure that out to start. We know that from A to B and B to D will actually give us the height of the yellow triangle here. So we're going to add these two values together, and I'm going to do that very quickly here. 250 and 550 will give me 6, 8. Should give me 800. Okay? So the height of this longer triangle here should be 800 meters. Okay? This is excellent. In similar triangles, we need to get similar sides. So since we know these are all set up the same, because this height triangle here is the same height or is the same side in all the triangles, we can use that as our scale factor or our ratio value. So because we have the hypotenuse and we talked about the things that we're going to need are technically the hypotenuse of the magenta triangle and the hypotenuse of the yellow triangle, luckily we already have the hypotenuse of the green triangle. So once we find the scale factor from green to magenta and from green to yellow, we can use that scale factor to find this hypotenuse and this hypotenuse. Okay? So the very first scale factor here, we're going to divide the sides in order to figure out. You can kind of write it as K as your scale factor. You can use a formula like this. K is equal to side of triangle 1. So ST of triangle 1 divided by side of triangle 2. It's the best way I can kind of describe it right now, okay? So we'll call magenta triangle, triangle 1 in this case, and green triangle, triangle 2. So our K, or our scale factor between these two, is going to be 275 divided by 250. And again, we have to make sure they're the corresponding side. So we'll get a calculator out for this part. 275 divided by 250. This is a scale factor, 1.1. Great. So what that means is interchanging between these, if I'm going from here to here, I multiply by 1.1. But if I'm downsizing, if I was going this way, I would divide by 1.1. Because this is the information we do have and this is our unknown, we're going to be multiplying up. So we're going to take 420, and to figure it out here, we're going to multiply by 1.1, our scale factor. Okay, so we'll take our calculator out again. I think 1.1's already there. Great. We'll use 1.1 times 420, 462. Perfect. So 462 meters. I'm going to put it back in the original here just because it'll help us with our view. So that means this distance here is 462 meters. Good to know. Last thing we need is the larger one so that we can subtract these two values. Well, we're going to have to find another scale factor. I'll use a different color. Do I have any colors left? Oh, I have colors over here. Orange. Okay. We need to go from 450 to 800. Same idea. We need to find that K. Maybe you can represent it like this. Side of triangle 1 over side of triangle 2. Same idea. I just used this symbol instead of a letter. So our K here is going to be equal to 800 over 250. So take our calculator out again. 800 divided 250. 3.2. So our K factor from green to yellow is 3.2. That means, I guess I should maybe redraw this. We'll just kind of slip it in here. This is multiplying by 3.2. I'm no longer orange, am I? Sorry, I don't see colors amazingly. There we go. Times 3.2, and vice versa. But what's key here is, again, we need this hypotenuse value. So we're going to have to take 420, which is the hypotenuse of the green triangle. So we need to take 420, and we have to multiply it by our scale factor of 3.2, and that will give us the hypotenuse of the yellow triangle. So 420 times 3.2 equals 1,344. 1,344. So, again, from our original, I'm going to try to make an overarching one here. This distance here is 1,344. So, let's kind of zoom out here so you can see what we've done. We need to find out the remaining distance for the tunnel. We have this distance, and we have this distance, and we have the overall distance. That means we're going to need to subtract the green hypotenuse and the magenta hypotenuse from the yellow triangle hypotenuse to find out the time. So we're going to take those three values, 1, 3, 4, 4, and put them all in black now. So 1, 3, 4, 4 in meters. Subtract our 420, and then again, tactically subtract, what's the other one? 462. So that's going to give us an answer. Whatever that answer is, we'll subtract 462 from it to get a final answer in meters. So we'll do this as our first step. 1, 3, 4, 4, subtract 420. 1, 3, 4, 4, subtract 420. 9, 2, 4. And then when we subtract this, I think it'll be faster this way. That's not 5. That should be 8, 6, and 4. 462 meters. So our tunnel should be 462 meters, which is the exact distance of the other one. I'm going to double check that just to make sure. Maybe it's just a coincidence that the distances are the same. 4 subtract 4, 6, 2 equals 462. Okay, yeah, that's right. The tunnel should be 462 meters in length.